troubleshoot electrical surges in your phone system, firstly verify grounding. Ensure proper grounding of the main phone entry and all phone jacks. Use a multimeter to test the grounding resistance. It should be less than 1 ohm. Secondly, consider lightning protection. Consider installing a lightning arrestor device specifically designed for phone lines. This device will divert excess electrical energy caused by lightning strikes to ground. Thirdly, check the wiring. Inspect the phone wiring between the house and shop for any breaks or damage. Ensure the wiring is securely terminated and spliced properly. Fourthly, inspect the circuits. Verify that the phone system is on a dedicated circuit separate from other high-power loads. Overloading a circuit can lead to voltage drops and increase susceptibility to surges. Fifthly, consider power supply considerations. Ensure the power supply for the phones is stable and free from fluctuations. Consider using a voltage regulator to stabilize the power supply. Sixthly, reduce line length. As the phone line length increases, the susceptibility to surges increases. Consider shortening the line length between the house and shop if possible. Seventhly, use higher quality surge protectors. Not all surge protectors are created equal. Invest in higher quality surge protectors specifically designed for telecom applications. Replace the faulty laptop protectors with more robust models. Eighthly, consider a battery backup. A battery backup system can provide protection against short-term power outages caused by surges. This will allow the phones to continue operating briefly during a storm. Ninthly, contact the phone company. If all else fails, contact your phone provider and inquire about any known issues or recommendations in your area. They may have specific suggestions based on your location and infrastructure. As an additional tip, unplug phones during storms if possible. Install overvoltage protectors on all electrical circuits. Regularly inspect and maintain your electrical system to identify potential hazards. Grounding is a critical aspect of electrical safety and surge protection. A proper ground provides a low-resistance path for fault currents and surge energy to return to the source or dissipate into the earth. This helps to prevent voltage buildup that can damage equipment or pose a safety hazard. To ensure proper grounding, firstly, use a multimeter to measure the resistance between the ground point and a known good ground, such as a metal water pipe or grounding electrode. The resistance should be less than 1 ohm. Secondly, inspect the grounding electrode and ensure that it is properly sized and installed according to local electrical codes. Typically, a grounding electrode is a copper rod or plate that is buried in the earth. Thirdly, check all ground connections to ensure that they are clean, tight, and free from corrosion. Loose or corroded connections can increase resistance and impair the effectiveness of the ground. Lightning arrestors are devices that are designed to protect electrical equipment from voltage surges caused by lightning strikes. They work by diverting the surge energy to ground, preventing it from reaching the protected equipment. When selecting a lightning arrestor, firstly, choose a model that is specifically designed for the type of equipment you are protecting, such as phone lines, data lines, or power circuits. Secondly, ensure that the arrestor has a sufficient surge current rating to handle the expected lightning activity in your area. Thirdly, install the arrestor as close as possible to the equipment it is protecting and ensure that it is properly grounded. Inspecting phone wiring is crucial for identifying potential problems that can lead to surges or other electrical issues. Firstly, visually inspect the wiring for any signs of damage, such as cracks, fraying, or exposed conductors. Secondly, check the connections at all terminals and splices to ensure that they are secure and properly insulated. Thirdly, use a cable tester to verify the continuity and integrity of the wiring. If you find any problems, repair or replace the wiring as needed. Dedicated circuits are electrical circuits that are used to power only one type of equipment or appliance. This helps to prevent overloading of the circuit and reduces the risk of voltage drops and surges. Firstly, identify any circuits that are currently powering multiple high-power loads such as computers, printers, and other office equipment. Secondly, separate these loads onto individual dedicated circuits. Thirdly, ensure that each dedicated circuit is properly sized for the load it will be carrying, and that it is protected by a circuit breaker or fuse of the appropriate rating. Voltage regulators are devices that are used to stabilize the voltage supplied to electrical equipment. They work by automatically adjusting the output voltage to compensate for fluctuations in the input voltage. This helps to protect equipment from damage caused by overvoltage or undervoltage conditions. To use a voltage regulator, firstly, select a model that is compatible with the voltage and current requirements of the equipment you are protecting. Secondly, connect the regulator between the power source and the equipment, following the manufacturer's instructions. Thirdly, adjust the regulator's output voltage to the desired level. Shortening the phone line length can reduce the susceptibility to surges by minimizing the amount of wiring that is exposed to lightning strikes or other sources of surge energy. Firstly, evaluate the current phone line layout and identify any unnecessary line for loops. Secondly, reroute the phone line to take the most direct path between the house and shop. Thirdly, use high-quality connectors and termination methods to ensure a secure and reliable connection. Not all surge protectors are created equal. High-quality surge protectors typically offer better protection against surges due to their superior design components and surge current ratings. When selecting surge protectors, firstly, look for models that have a high surge current rating, typically measured in kiloamps. Secondly, choose surge protectors that use metal oxide varistors or silicon avalanche diodes to suppress surges. Thirdly, select surge protectors that have a fast response time, typically measured in nanoseconds. Battery backup systems can provide protection against short-term power outages caused by surges by providing a temporary source of power to keep the phones operating. Firstly, choose a battery backup system that is sized to provide enough power to run the phones for the desired amount of time. Secondly, connect the battery backup system to the phone system following the manufacturer's instructions. Thirdly, test the battery backup system regularly to ensure that it is functioning properly. Contacting the phone company can be helpful in identifying any known issues or recommendations in your area. They may have specific suggestions based on your location and infrastructure. Firstly, gather information about the surge problem, such as the frequency, timing, and severity of the surges. Secondly, contact the phone company's technical support department and explain the problem. Thirdly, ask the phone company if they have any known issues or recommendations for your area. Unplugging phones during storms can help to protect them from damage caused by lightning strikes or other sources of surge energy. Simply disconnect the phone line from the phone and unplug the phone from the power outlet. Overvoltage protectors can provide protection against surges on all electrical circuits. These devices work by diverting excess voltage to ground, preventing it from reaching the protected equipment. Firstly, install overvoltage protectors at the main electrical panel and at any subpoles. Secondly, choose overvoltage protectors that have a high surge current rating. Thirdly, ensure that the overvoltage protectors are properly grounded. Regularly inspecting and maintaining the electrical system can help to identify potential hazards and prevent surges. Firstly, visually inspect the electrical system for any signs of damage, such as cracks, fraying, or exposed conductors. Secondly, check all connections to ensure that they are clean, tight, and free from corrosion. Thirdly, test the grounding system to ensure that it is functioning properly. Consider the environmental factors that might be contributing to the surges. If the area is prone to frequent lightning storms, installing a more robust lightning protection system might be necessary, including lightning rods and the built-in and surge arresters on all incoming power and communication lines. If the power supply from the utility company is unreliable or prone to voltage fluctuations, consider installing a whole house surge protector and a voltage regulator to stabilize the voltage. The subfed electrical panel that you have in your shop could be causing a ground loop if it is not properly grounded back to the main electrical panel in the house. A ground loop occurs when there are multiple paths to ground, which can create circulating currents that can interfere with electronic equipment and increase the risk of surges. To prevent ground loops, ensure that the sub-panel is grounded back to the main panel with a dedicated grounding conductor. Do not rely on the metallic conduit or other built-in components to provide the ground path. The type of soil around the grounding electrode can affect its effectiveness. If the soil is dry or sandy, it may not provide a good electrical connection to the earth. In this case, you may need to improve the soil conductivity by adding a grounding enhancement compound or by driving the grounding electrode deeper into the ground. The PVC conduit that the phone line is run through between the house and the shop may not provide adequate shielding from electromagnetic interference, which can also contribute to surges. Consider using a shielded cable for the phone line and ensure that the shield is properly grounded at both ends. 4-wire phone system often refers to a type of telephone wiring that uses 4 conductors to carry voice and data signals. Traditionally, telephone systems use 2-wire connections, where one wire carries the signal and the other serves as a return path. However, in 4-wire systems, 2 wires are used for transmitting signals, and the other 2 wires are used for receiving signals. This configuration allows for improved signal quality, reduced interference, and the ability to support more advanced features such as conferencing and data transmission. A structured wiring system with Cat5e cables is a modern approach to wiring buildings for communication and data transmission. It involves using a centralized distribution panel to connect all the various devices and outlets in the building. Cat5e cables are used to carry the signals between the distribution panel and the devices. This type of wiring system offers several advantages, including improved organization, flexibility, and scalability. The importance of straight runs in structured wiring relates to the performance and reliability of the network. When cables are run in a straight line without sharp bends or kinks, the signal quality is maintained, and the risk of interference or signal loss is reduced. Straight runs also make it easier to troubleshoot and maintain the wiring system. If cables are tangled or poorly routed, it can be difficult to trace and identify problems. The distance between the house and the shop, which is 80 feet, is relevant because it can affect the signal strength and quality of the phone line. As the distance increases, the signal can become weaker and more susceptible to interference. This can lead to dropped calls, poor audio quality, and other communication problems. In cases where the distance is significant, it may be necessary to use signal boosters or repeaters to amplify the signal and maintain its quality. A subfeed from another shed refers to an electrical configuration where the shop receives its power from a secondary electrical panel located in another building, which is the shed. The main electrical panel in the house is the primary source of power for the entire property. When the shop was originally powered from the house, it was likely connected directly to the main panel. However, after the teardown and rebuild, the shop's power source was changed to the sub-panel in the shed. This configuration can have implications for the grounding and surge protection of the shop's electrical system. It is important to ensure that the sub-panel is properly grounded and that all electrical connections are made in accordance with local electrical codes. The phone system's sensitivity to electrical surges suggests a few potential problems that need to be investigated. Firstly, the grounding of the phone system might not be adequate. A proper ground is essential for diverting surge energy away from sensitive electronic equipment. Secondly, the surge protectors being used might not be of sufficient quality or capacity to handle the surges that are occurring. Cheaper surge protectors often have limited surge handling capabilities and can fail quickly under repeated surges. Thirdly, the wiring and connections in the phone system might be loose or corroded, which can create impedance and increase the susceptibility to surges. The fact that the laptop protectors are failing while the commercial-grade surge protector is not suggests that the laptop protectors are absorbing the brunt of the surge energy. This could be due to their location, their design, or the fact that they are simply less robust than the commercial-grade protector. It is also possible that the commercial-grade protector is not functioning properly and is not diverting the surge energy as effectively as it should be. The teardown and rebuild of the house and the subsequent changes to the phone and electrical systems could have introduced new grounding issues or other problems that are contributing to the surges. It is important to carefully inspect all the wiring and connections to ensure that they are properly made and that there are no loose or corroded connections. The daisy-chained 4-wire phone system that was previously used might have been more resistant to surges due to its simpler design and fewer connections. The structured wiring system with Cat5e cables is more complex and may be more susceptible to surges if it is not properly installed and grounded. PVC conduit, while providing physical protection for the phone line, does not offer any shielding against electromagnetic interference or surge energy. This means that the phone line is still vulnerable to surges that can travel through the air or through the ground. Installing a shielded cable for the phone line can help to reduce the susceptibility to surges. The fact that the shop is sub-fed from another shed could be contributing to the surges if the grounding and bonding between the two buildings is not properly done. It is important to ensure that the grounding electrode system in each building is properly connected and that there are no ground loops or other grounding issues. Consider consulting with a qualified electrician or telecommunications technician to thoroughly inspect the phone and electrical systems and identify the root cause of the surges. They can perform tests and measurements to assess the grounding, wiring, and surge protection and recommend appropriate solutions.